Hello guys, how are you? I think everybody is fine. So let's start our today's session. And today basically I am going to explain you the project called image caption generator. Please listen this project, and if you want to do a project in your college time and want to do a something amazing like amazing project. Basically this project is very good if you will do it in your college time called image caption generator. So basically in this project, if you pass this image of anything, then this will generate the caption of that image. That means basically, suppose now I am creating a video. So if I take an image of myself and pass to this my model, so this will generate like text, like a person is creating like a person is sitting beside the computer and creating a video, something like that. This will be able to predict it. So let's start our journey of creating a image caption generator project. So let's start it. So where is this Fickler image caption generator? Yeah, so basically this is our aim. Welcome to our best amazing project. So in this project basically if we pass an image like this or this, so our model will predict a group of peoples on a beach with some surfboards, or group of peoples are standing in the water. So this will be able to predict it like this. Even like how this model is good, you are very good. And this project is very good if you will show this project in your college life or in a college time. If you will do this project in your college project, they will be very happy with your project. So let's start like to build this project, and even I will give you the GitHub repository to this project to in the description. You can find it out, and also I've shared the data set so to train this model. So let's start the journey of building image caption generator project. Let's start. So that's for the project description. Let's see the code. How to build this project. Yeah, I think you are able to see that, or basically I will open this in the in the GitHub bit. Here you can find out in Jupyter notebook. It will be shown in a very good way. Wait 1 minute guys, I am loading it. Image caption generator. This is the project, and you will find it out in the GitHub also. Let's explain the project. Let's start our explanation. So firstly, to do this project, I am basically doing this project in TensorFlow library. This library I think you already know, like NumPy, Panda and CV2, all of this. The best library for creating a deep learning model is called TensorFlow. If you know TensorFlow, this is very good. So let's start our journey to creating the model, project called image caption generator. So firstly I have to load this image dataset. Let's explain it some few things, like where you can find out this dataset. To train this model, basically you can find it out at a dataset called Fickler 8K dataset. You can search it in Google, you will be able to find out. Or if you don't able to find out, I will paste this repository in a GitHub, so you can also find it out, this dataset. Or I will be paste a Google Drive link of this dataset. You can download it from there also. So let's start our journey. So let's see the dataset, how this will looks like. So this is our dataset. We have approx 8,000 of images. Here you can see that like different types of images I have. You can find it out. Like these are some images. So basically what we have to do for this project, so suppose this is our image. For every corresponding image we have a training data set. So in training data set, basically what we have, for every corresponding image, here you can see that, wait 1 minute, inside Fickler text data and tokenization, here you can find out. So for every image you can say that this is the image number, and for every image number there will be 5 captions like 0 to 4. So for every image we have a 5 caption, like you can see a child in a park dress is climbing up a set of stairs in the empty bay, a girl going into a wooden building, a girl climbing into a wooden playhouse, a little girl climbing the stairs to the playhouse, a little girl, so something like that. For every corresponding every image we have 5 captions. So here you can see that we have loaded this image and we have 8091 images, and for every image we have 5 captions. So I have loaded this captions, so you can see that these are some captions of that every images. Like these are some images name, we can see that. And here I have loaded the caption in the UTF-8 format. So here you can find out for every image caption, for every image name we have 5 captions corresponding to that image. So we have to build a model, so where we will pass image and we can generate a caption like that. So this is our aim. So how to build it, let's talk to this, like how to build this type of model. So to build this model, basically firstly what we have to do, uh, to doing this first project, firstly we have to think it like this is our data set. The next step, after loading the data set, the cleaning the data set. Cleaning the data set is not a very tough thing. So to cleaning the data set, we have to think it like how our data looks like to train this model. So this is the best thing if you are able to think it like that, ki how our data set will looks like to train this model. So basically firstly you have to pass a image, and for this image basically you have to pass a caption for also. How this will be done, so let's start talking to this. So what we have to do, basically firstly we have to pass this image features, or not directly pass this image, we have to pass this image and extract the features. After extracting the features of that image, we have to pass this image and pass also a input, like this input is done like image, and the second input is to this model is like a bird. Basically firstly we don't know any bird, so we have to pass a startup sequence bird, we will append it at the time of training. So startup sequence is passed. So by passing this image caption and startup sequence, we will say that if you have this, then you have to predict the bird like this a. And the next time if you have an image like this, suppose that this is your image features. So if we pass this image features and a pass a, then you have to predict a child. If we pass this image features and pass a child, then you have to predict it in. So basically we have to predict the next bird. If we have a this image feature and this image ka caption, then you have to predict it like a. If we have this image features and this child in then you have to predicted pink. So that's how we will train this model. So now let's create our data set which will looks like this. So how to create this? So basically firstly we have to extract this image feature. So now talk to, let's firstly talk it like after creating the image feature. Now we have to convert this our image, this is like NLP text into some way, so that at the time we will pass a, then you have to predict a child. So to convert this, basically we will use a one hot encoding, and after converting one hot encoding, basically we will create embeddings model using a LSTM, or using a TensorFlow we will create a embeddings, and after embedding creating we will pass this as a, if we pass a, then you have to predict a child, something like that. So let's start our journey to creating this may be something confusing at the time. I will if you see below, you will able to understand like how I am, what I am talking. If you are able to understand it, that I have talked, this will be great. And if you will understand, you will be able to do this project easily. So let's start. So firstly, we have to for image processing, basically we have to extract the feature. So to extract the feature, basically we have to pass this for every image to a ResNet model. So basically we are using ResNet 50 model. You can use ResNet 101 or any model which will be good. So basically what we have done, if we pass every image to this ResNet model, this will predict the class of that image, like 1000 class may be predicted. But we have to remove this last layer. Here you can see that, if you are able to see that here, if you pass this image to this model will predict 1000 classes of that image. But we have to remove this layer and we will only extract 2480 features of that image. So how to do this? So basically my model basically insert model and output equal to last layer, and our last layer is basically minus tooth layer. Here we have defined last layer equal to insert model dot layers of minus 2 dot output as a this our last layer. That's how we have to do it. So by passing this, we will get 2480 features. So now our model is done. Now we have to pass every image to this model. So to passing this image, this is the function. So for we have to every image we have to pass in from this model, from this function. And this function basically creating this image features. Basically image feature is a dictionary, and in dictionary basically image name and predicted by this model, my model dot predict. Or basically we are reshaping into 2480. This model is basically incept model, basically we are talking about in upper. So or basically the ResNet 50 model. So every image we have passed to ResNet 50 model and extract the good features from that image. Now our image work is done. Now we have to convert this NLP text into some encoding or one-hot encoding, so that our, if we pass this and first letter, then we have to say that you have to predict it the second letter. If we pass a girl, then you have to predict it swimming, something like that. So let's work on this. So now we have to create a caption dictionary. So in caption dictionary, basically we have to create a dictionary for every words. Like here you can see that for this image name we have a this dictionary, or we can say that here's the list of caption of that image. If we image name this and we have a caption for that image, so this is have a caption dictionary. And after that basically we are seeing like if we have an image like this, then we have 5 captions corresponding to every image. You can see that sounding good on chair, hearts, children, pump, something like that. A child in dress looking at sparkle, something like that. So now for preprocessed text, so basically we have already I have already say that like we have to add start of sequence and end of sequence in our data set to basically starting the sequence. So here you can see that this is our caption dict. Inside a caption dict you can find out, so this is a start of sequence and end of sequence is appended for every sequence. So why we are appending it? Basically at the first instance we don't know like where to start. So we don't know like we can pass image, but what is the sequence like at the initial stage we don't know. So that's why we are say that if we have a image features of this and caption like start of sequence, then you have to predict it a. That's how we will train our model. And that's it for this. And what we have to do it, that's how this will work. Start of sequence is added and end of sequence by, so end of sequence so is added. So to know that our the caption is ended, now we have to don't predict it next. That's how it is work. Otherwise it will predict it until it will not stop. So the to stop this prediction we have to add a end of sequence. Now we have to count upwards, like a start of sequence how many times it's coming, a how many times a black how many times it's coming. So basically we are creating a dictionary now. So we have a dictionary of 3962 words. But here's just the one problem is there, like out of vocabulary. To avoid this out of vocabulary, basically we are creating a new like length of new dict and name this as a out. So if a new word will came, like basically we are predicting a new word, so this will not be happen, but some out of vocabulary word will be happened if we train suppose if at a time of training some new things will be happen, then this will can't able to predict it. So like we don't have a training data set suppose of any girl which may be doing like something. So if we don't have a at the time of training this data set, data don't know the model, so this can't be able to predict it. So to avoid this, basically we will add out. So like I think you will already know that like out of vocabulary means at the time of training we will not pass any words, like here we will training on this words, but maybe the dictionary of real time may be different, so that's why we have to add it. Now we have to convert this our vectors into encoding. So here you can see that we have convert our this caption dictionary into one hot encoding vector, not a one hot encoding vector, basically it's a encoding vector, but here you can see a different length of every sentence is different. This known as one hot encoding or maybe one hot encoding hot, basically vector encoding or one hot encoding. You can see that you can say that one hot encoding, not a this is not a one hot encoding. Basically this known as I don't know the exact name. Encoding basically we can say, so basically we have give a number to every, basically here is some word is there, so a one is known as startup sequence and two is known as a and four may be known as the something maybe. So basically we have convert, so our model will understand, basically our model will understand only maths, so that's why we have converting every sentence NLP into a math. Now basically there is some problem. Basically the problem is like every sentence is not of same length, so we have to convert every sentence of same length, so we have to use categorical and padding, like padding we have to convert it about this sentence and also like categorical. So to do this, basically in X basically we are appending the image features, and by in basically what is our input and what is our output. If we pass input this, then you have to predicted output. So let's start our generating. So to this is our generator. So this is our photo is appended, and corresponding to this photo we have appended this basically input vector. So input, suppose our input vector is start of sequence, so at the start of sequence then you have to predict this output. So the output is basically maybe output is every time is basically a one word, so that's why we are converting a two categorical. Padding sequence, basically we have adding some zeros at the end of the sentence. Here you can find out this 1 2 3 4 5 6 7 9 8 2 and added this 0. So basically we have defined that the maximum length of this hour is 34, maybe max length, and max length is 34. Yeah, so we have defined that the max length of our input sequence is 34, so we have to define this sequence length, input sequence length, and this can't be changed. This is fixed 34 every time, and output sequence is also fixed. Here you can see one some dots are there, but output sequence is basically convert this to categorical. To categorical means where this sentence is present we give one and everything will be rest will be zero. So out sequence, that's mean number of vocabulary size is basically our 3000 something is there. Yeah, 3962. Here you can see that caption dict and vocab size. Number of classes is equal to vocab size, and vocab size is basically length of new dict, and new dict length of new dict is basically 3962. So we have converted every, if we pass, we say that to our model, if we pass this input, then you have to predict it this output, something like that. So here you can see that the length of x is 96,564. So how our 8,000 data will be converted into 96,000? Now this is the question. So basically here we have converted, for every sentence we have created many sentences. So like suppose this is our caption, so for this caption we have created 1 2 3 4 5 6 7 8 9 10 10 basically point is created for here also 10 10. So you can assume that, okay, for every sentence, for every image, there's 5 captions. For 5 caption into 10, 50 different like sentence or 15 data point will be created for every image. So now assume like how much data set you have, and this is your image data set. And by input is basically your input sequence. So input sequence is basically 96,005 cross 34. So 34 is basically means this is your input data where like we have given a number 1 2 3 4 something like that, and after that we have appended 0. And by output is basically is a categorical variable, and categorical means basically we have converted our output in a categorical, and where this bird is present we have given a 1 and rest will be 0. And this will be 3963 dimension vector basically every x20. You can see that by 20 if we pass input like startup sequence the and something like that, then you have to predict it. Like here you can see that 124 means 124 horse, start of sequence a horse, then you have to predict it. And so that's how where we are, yeah. So if this then you have to predict it horse, something like. And start of sequence the horse and something like that you have to predict. If we pass start of sequence the horse, then you have to predict it end. So where it is end present, this will be 1 and everything rest will be 0. That's how this will be done. Now let's talk about embedding model. Now create our embedding model, and then we will create a language model. This is our language model, and this is our not embedding, this is our language model, we can say, or image model. So image model is very simple. We have firstly convert our image to a 2040 dimension of image, and here basically we have already image features of every image, and let's pass this image feature to this model. And after that basically we have converted, apply a 128 number of features basically. So this will be converted into 128 features, and after we have applied a repeat vector of max length. So basically we are converted this input image. Firstly we will take this input. I think you already know this CNN model. So basically this is a CNN model, and we have applied a ReLU as activation function. And so this will be converted our input into a 34 cross 128. Why we have converted this? Because we have same as basically we have to concatenate both input, this image input and a text input. So to concatenate basically we have to convert this length of this both same, then we are able to concatenate it. So that's why we have applied this. After inputting basically we have converted into 34 length. So here you can also see that now we have a firstly take input as a this Banhart encoding vector. We will not say Banhart encoding. Basically this is a pet sequence, or basically called, we can say that a Banhart encoding vector. So this not, we can say Banhart basically one is present and everything will be there. So by output we can say that this is our Banhart encoding, but this is not a Banhart encoding vector. So basically we have to take input this and convert this input into a embedding. If you know embedding, then it is fine. Let's explain the embeddings, like what is embedding and how to use embedding and all of these things. So embedding is basically a numerical representation of English. There's suppose I am talking my name is Naren. So my name is Naren. How will this look like in math? So we have to convert this into a embedding. So if you apply something a numerical representation in math, and then suppose mm, if you know like uh, how to explain embeddings in a easy way. So suppose if I will, yeah, let's talk. Suppose there's a man. If we say in a real world, like there's a man, if we minus woman, then you will get a transgender. So in math, if you do apply this equation, if you convert men into embedding and women also an embedding, and if you will minus apply a subtraction, and then you will get some embedding vector, because this is some numerical representation. If you apply, then you will get some vector, and again if you convert this embeddings into a English, you will get transgender. That's how this will be able to do it. So if that's why we are doing converting every sentence into a embedding. So that's embedding is basically nothing but a numerical representation. So if you apply some numerical calculation inside of this, you will get a same vector as a English. I think you are able to understand it. So inside this basically we have to pass our the sentence input dimension is vocab size. So vocab size basically, like here we are defining like output dimensions, like how many dimension you want to create a embedding. So we have defined it. This is basically a hyperparameter. You can define it any number of dimension, output dimension. So we have defined 128 dimensions, and input length is max length. So we have defined it like we will pass a max length of 34 input length, and you have to convert this input sentence, English sentence, or maybe a numerical representation sentence into 128 output dimension with a vocab size of this much. So we say that we have a different like this much of vocab size. So we will pass 34 into 128, and after 34 128 basically we will apply LSTM layer. So LSTM will help us to basically, we can say, LSTM is basically a long short term memory. So this can able to understand it your our mathematical like NLP related task very well. This will able to remember what we have to remember and what we have to forget. If you will listen or see my previous lecture of NLP, you are able to understand like what is LSTM, RNN, LSTM, RNN, bidirectional LSTM, RNN, everything I will be explained. Also, I have explained the transformer, which is very good. If you are able to understand transformer, you are easily able to understand it this. So the again we have to convert this. Here we, if we don't apply this, then we can't able to convert like apply a concatenation. So that's why we have to apply a turn distribution layer with a dense layer 128. So that's now we have a output of 34 comma 128 and 34 comma 128. Now we can join this both model, and after joining, like here you can see the concatenation of an image model and language model, both are being concatenated. And on top of this concatenation we apply again LSTM and dense, and we apply a vocab size of output size. So every time we will say that like this is our output length. And now we have to apply a softmax activation function. So softmax basically there are many types of activation function is there. Basically now we are applying a softmax. Basically this is our classification model, we can say that. I have basically creating a classification model of a class of 3960 something like vocabulary size of our classes are there. That's how. And this is our model. Basically in this model, input is image input and language input model, and output will be out. This is our output. And we will apply categorical cross entropy. You can also apply sparse categorical cross entropy if your output is not a one-hot encoding. Basically we have converted our output into a sparse matrix, so we don't have to convert it again. So and apply atom optimizer. I think you already know this. Atom optimizer is the best optimizer, and 99% cases or 99.99% we will use atom optimizer, because inside optimizer, if you see my deep learning playlist, I think you will be able to know that why we have to apply it. So inside our atom optimizer, basically all of these things like learning rate is also variable, and like momentum is very low, and something like this. So that's why we have to apply it. And metrics, accuracy metrics, to see the performance of that model. So let's see our model, how this will looks like. So here you can see that this is our final model. So in this model, here you can see that this is our image input, 2480 input as a image, and converted into 34,128, and here we are passing our input sentence. Suppose we have a sentence of I love, then what is the maybe the next word. So this model will predict. If we have a image features this, and like caption of firstly we don't have any caption, so start of sequence is passed every time, and then we will able to predict like the next word, like maybe the a. So at the second instant we will pass this image feature same, and the second will be start of sequence and a. So if we pass this, and we have to convert this a into 34 dimension. So basically we apply startup sequence have a number maybe 1, and a maybe a number of 2. So 1 comma 2 is passed, and everything will be rest will be 0. So then we have to pass this, convert 34 into 128, then we have to concatenate and apply LSTM layer and activate. This is our final last layer, and that's how it will work. And here you can see that I have trained this model of 2 epochs only, and after training the 2 epoch I will get a 11% accuracy. But after training I think 100 or 200 epochs, you will get like 70 to 80% of accuracy. That's how it will work. Thank you guys. And here you can see that this is our prediction. We will get a model, and then we have to save it in a .h file, or you can save it any format, and this is the function to predict it. Here we are basically passing this image only, and image after. So text input initially will be startup sequence, and the startup sequence will be appended every time of this will predicted new things. That's how this will work it. Thank you guys. I think you are able to understand it. If you are able to understand it, this is very good project. So that's how it will work. Let's meet in the next lecture. And I think I have explained the image caption generator project in a good manner. If you are able to understand it, please hit subscribe button, and please share my channel to your friends, so they will be also subscribe my channel. Please do it, subscribe my channel as soon as possible, and please guys, do it whatever you are like. Jai Hind, Jai Bharat. Let's meet in the next lecture, and in next lecture I will be explaining our next project, maybe a different one. Thank you guys.